We examined several of the themes surrounding the GTA case study and decided to concentrate on product tracking through the cold chain. Issues relating to cross-border cold chain can be split into two. Firstly, the recording of information for regulatory and product quality were considered. For example, requirements relating to e-pedigree compliance and the recording of temperature and other events during the shipping lifecycle. Secondly, the requirement to reduce costs motivated a review of specific cost areas such as the processing of orders, the cost of identifying container contents, the expense of delays causing degradation to the vaccine, and losses due to misplaced product. An assumption has been made that patient safety is of primary concern. An adverse reaction to mishandled vaccines would cause extreme brand damage and loss of revenue. When examining patient safety, there are several characteristics of vaccines that must be considered. Vaccines and diluents are biological substances that become less effective if frozen, overheated, or exposed to sunlight or fluorescent light. The problem is that the freezing point of a vaccine is often unknown and the loss of potency following freezing occurs instantly. Therefore, it is safer to store the vaccine above 0 degrees. In addition, vaccines closer to expiration date are more vulnerable to degradation. The proposed solution is the introduction of RFID tagging. This resolves the issues at a low marginal cost. Whilst there may be considerable implementation costs, these will be recouped by saving one batch of vaccine and might be borne by the supply chain to reduce overall cost. Actors in cold chains are already taking advantage of RFID. The technology allows product identification without unpacking, reducing costs and making it easier to control temperature through the chain. In 2006, pharmaceutical regulators in Florida published requirements for e-pedigree with the aim of improving traceability and combating counterfeit drugs. Actors in the chain can now record information regarding the parcel transport directly in the RFID tag. Improvements to battery life and sensor technology enabled recording and reading of real-time information such as precise location, vibrations, temperatures, humidity, and intrusions. This helps to further validate product quality during shipping. Most promising applications are still to be developed. More than just identification, RFID tags in smart parcels would enable them to interact with their environment, sending alerts to the warehouse where the parcel is stored, for example. Smart parcels may also be equipped with RFID reading technology, monitoring their immediate environment. The proposed solution considers the use of active UHF RFID tags. An active tag can store up to 4 million temperature readings and allow uninterrupted monitoring for 1 to 2 years. The tags are compact, lightweight, waterproof, shock and tamper resistant. Most importantly, the recipient can analyze temperature statistics and threshold excursions on the visual display of the reader before accepting liability for a shipment. However, there are issues with the solution that must be considered. For example, current RFID tags can only be tracked by scanning the tag at each location. Further, a secure wireless network is needed for readers to communicate the real-time information to servers. This requires investment in many components and systems such as hardware, middleware and software. As highlighted here, there are many advantages to RFID tags over other tracking systems such as barcodes. All of these benefits would accrue to GTA if it was to adopt the solution proposed. These advantages either relate to the ability to record information or the potential to reduce loss. However, there are disadvantages to using RFID. Whilst the tags themselves are robust and are unlikely to fail, there are issues with jam signals or signal collision. The most significant issue, though, may be those relating to security and the potential for information about the content of containers being intercepted. In order for RFID to improve shipment tracking, there needs to be an agreed standard allowing interoperability between actors in the supply chain. Each one of these actors must be able to read and interpret an RFID tag using its own equipment. The Irish, UK and US Communication Commissions have approved compatible UHF frequencies and power. The ISO has established standards for UHF RFID and is also responsible for standards relating to other frequencies. EPC Global has created a standard for UHF air interface protocols that now form part of the ISO standards. There are two approaches available in regard to storing data on the RFID tags. The first is EPC Global's license plate approach of storing EPCs on the tag. This uses currently implemented standards but requires back-end support. The second is the ISO's approach to storing product information directly on the tag. This removes dependence on the backend system but requires more complex data structures.